సీరియస్‌గా ఏం లేరు. అంతా చాలా లైట్‌గా ఉన్నారు మీరు పిల్లలు. Okay. Okay, good afternoon all of you. Good afternoon. Okay. So we shall see what we have discussed in last class. Okay. So let me share my screen. So after discussion or after discussing what we have seen in last class, we'll go to today's class. Okay. So a summary of last class. Just go through. What was the summary of last class? Summary of previous class. Let me revise once. In previous class, in previous last two classes, we are being discussing a analysis of a CE amplifier. Yes or no? Analysis of a CE amplifier. So when you want to analyze the CE amplifier or any configuration, there are standard steps I have given. So what are those standard steps? Once again, I just wanted to revise. First step is draw the configuration circuit, whichever the configuration you want to analyze. Thus you're supposed to draw the configuration circuit. So what will be the second one? Second one is the draw the AC equivalent of that, AC equivalent of your above circuit. And third step is nothing but what is the third step, right? So when you're drawing a AC equivalent, what is the procedure that we supposed to follow? What is the procedure that we supposed to follow? Anyone?
VCC ground and capacitor should be short circuit.
Very good. VCC must be connected to your ground and capacitors are there, then they have to be short circuited. And what is the third one? Third one, after drawing a AC equivalent, we will be having some transistor. So that transistor must be replaced with a what do you call H parameter equivalent model. Yes or no? Replace the transistor with the H parameter equivalent model. So we supposed to do this. So after replacement, the fourth step is nothing but apply the KVL comma KCL comma, and you can say that current division rule, whichever is suitable. So current division rule and voltage division rule, whichever is suitable for calculating a AB comma AI comma RI comma R naught, we supposed to follow any one of them to calculate these parameters. Is it okay? Then this is what the procedure that we have followed, and we understood and we have completed analysis of CE and we have derived the expressions for that. So what is the first and foremost is the AI, current gain minus HFE by 1 plus HOE into RL dash. Okay. So similarly, second one we have calculated RI, HIE plus AI into HRE into RL dash. And third one is AB is equals to AI into RL dash by RI. And fourth one, R naught is equals to what is R naught? 1 by Y naught. Strictly speaking, Y naught is equals to HOE minus HRE HFE by, so some formula is there. So what is that? We can say HFE HRE by RS plus RB. Just once look at the formula. So these formulas that we have derived in last class, is it okay? So this was the last class. Of course, we have derived a fifth parameter as nothing but so Ri dash, which is nothing but overall input resistance. Sixth parameter that we have derived as R naught dash, and seventh parameter we have derived as AVS, and eighth parameter that we have derived as AIS. Okay, so this is what was the last class. Is it okay, sir? So always remember what are the formulas, that means what are the formulas that we have discussed. Okay, so to solve the, of course we have also solved one problem based on the CE amplifier. Are you people following what I am trying to say?
Yes, sir.
Yes,
Okay.
sir.
Okay, so this was the last class, and today we are going to learn about so what is that analysis of a CC. Put a subheading as, for today's class is nothing but a analysis of common collector configuration. Put a subheading. Analysis of common collector in brackets, of course you can say CC amplifier or a CC configuration. Analysis of a common collector configuration or a CC amplifier. Okay, so you just follow the steps what I have given. So what is the first and foremost step? Draw the
CC configuration.
CC configuration circuit diagram. CC configuration circuit diagram. Okay, so try to draw the CC configuration. When I say CC configuration, of course you know that collector terminal is grounded. Am I correct, sir? So this is the collector terminal. This collector terminal is grounded. This is the collector terminal. When I say this is the collector terminal, opposite to this one, what we will be having a emitter terminal. So emitter terminal, you will be having a something like R suffix E, and you will be having some biasing circuit R1 comma R2, and this R1 comma R2 form a biasing circuit. Someone is trying to join. Okay, so now, and this is RC, R1, R2. These are connected to where? Let me change the color. This is nothing but a VCC. Okay, so for this we will be having a C2, and you will be having a RL here. Okay, across which terminal we are taking an output? We are taking an output across this terminal. So what this voltage we can designate it as a VEC. Is it okay? So this is VEC, and at the input, if you observe, this is nothing but a C1, and to this we are also having a some RS followed by a VS. VS is nothing but a applied voltage, AC input. Okay, so this is VS. Now if you observe, this is the base terminal, and this is the collector terminal, and this is the emitter terminal. Now if you observe the input, where we are applying the input, right? Just look at VS. VS is applied between base comma collector, and output where we are taking, just observe emitter comma collector. Is it okay? Everybody able to observe, sir? So what is this configuration, you can say? What is the common terminal that you are observing in both this input and output? Can I say that collector?
Yes, sir.
So therefore this is a common collector configuration. So everybody able to observe or able to draw this circuit diagram for this? Please draw the circuit diagram. Please draw it. Draw the CC configuration circuit diagram. That's the first step. We have completed, see, similar steps that we are going to repeat for CE as well as CC as well as CP. And of course, after completion of this, CE with RE is also another circuit that we supposed to discuss. Sir, completed?
Yes, sir. Completed.
Rest
Yes,
of the
sir.
people. Yeah, rest of the people, please do respond. If you have completed, tell me. So make sure that one observation that I made is when you're drawing a transistor, they are unable to mention which one is a emitter terminal, which one is a base, which one is a collector. So this is a NPN, sir. When you're drawing in your records also, it is the observation that we are making actually NPN transistor. This is the NPN transistor symbol. Symbols also I have given. People, how they are writing, no? Something like that they are writing. If I ask which one is the emitter, they are saying this is the emitter, this is the collector. How will I know? The direction of the current which shows the emitter actually. Okay, so you're supposed to indicate it with an arrow. Okay, so this is how you're supposed to draw. That means you have indicated with a, this is the collector terminal, this is the collector, this is the base, and this is the emitter. Now serious observation is nothing but collector terminal is grounded. Okay, go for second step, those who have completed. Please let me know whether you people are still drawing. Completed, sir? Go for second step. What is the second step, Ray? Step 2. Step 2 is nothing but draw the AC equivalent of the above circuit. Draw the AC equivalent of above circuit. That above circuit is nothing but a CC configuration. Okay. So when you draw a AC equivalent of the above circuit, make sure that VCC we are going to connect it to a ground, and if any capacitors are there in this, those capacitors that we are making to a short circuit. Okay. So if I do it so, then what is the equivalent circuit diagram? This is the RS, anyway it won't change, and this is the VS. And what about C1, Ray? C1 is short circuited. This is what short circuited that I am representing here. And let me draw in a convenient way, because if I draw it, no, so it will take. Let me draw it here. The space will be sufficient. Now this is the RS. Please make sure that you're supposed to draw along with me, because the already steps you already know it. Now this is the base terminal. To the base terminal, we are also connected a biasing circuit R1, and this is the R2. So anyway, it is connected to your ground. So this is connected to your ground, and of course, let me change the color, because I just wanted to erase this one. You already know what to do. Okay, there is a emitter resistor here, that is R suffix E. Make sure that this is the emitter, sir, and this is also grounded. And connector terminal is connected to a ground. I just wanted to make sure that this is the base, and emitter and collector is grounded. This is the ground. Now at the output end, if you observe from this, we are taking a C2 is short circuited, and you will be having some RL here. And what is the current which is flowing through this is IL. Everybody understood this step? So
Yes, sir.
make sure that this collector terminal is connected to your ground. This collector is connected to your ground, and of course this emitter, across the emitter we are also having a emitter resistance RE, which is also connected to your ground. At this junction, you can replace this above circuit by something like this. Just make sure, observe how I am drawing. That means there will be a RS, same as it is, you can draw, and this VS. Someone is trying to join. What they will do after joining here? Okay. VS RS. This is the base terminal, and to the base terminal, if you observe, this is the emitter. To the base terminal, what we are having, R2 is grounded and R1 is also grounded. That means, so here it is forming some junction here. That means parallel combination. So that parallel combination, I'm redrawing something like this. So this is R2, and at this junction itself, we are also having a R1, and this is how we supposed to. And both are grounded actually. So both are connected to ground here. And of course, the collector terminal is also connected to a ground. Now across emitter, if you observe, once again designate this one as a base, and this one is a emitter, and this one is a collector. Now at the emitter, if you observe, from the emitter terminal, one RL is grounded. Of course, at the emitter itself, we are also having a RE is also grounded. So that means draw a line over here. So let this is the RL, and this is the RL, and from this emitter itself, we are having a emitter resistance that is also grounded. So therefore, let me change the color to indicate a highlight on a emitter resistance. So all these are connected to ground. Make sure that this line, this horizontal line, which is entirely grounded. So what is the current which is flowing, sir? IL is the current which is flowing. Everybody understood how I am drawing a AC equivalent circuit of the above circuit? Yes or no?
Yes, sir.
Yes, sir.
Very good. Please draw this one. So this 3-line horizontal line which indicates here, this is equivalent to, what is that 3 lines here which is indicated by, this is nothing but which is equivalent to. That means this one can be redrawn something like this. Nothing we did, we have connected all to the ground. So wherever junction is there, that's a parallel network. This the parallel network we have identified actually. Now, so what we have to do, sir? What is the third step, Ray? So far we have completed step 2. What must be third step, Ray? Step 3. Can you say something about here?
Drawing H parameter model.
Replace the transistor. Replace the transistor with its equivalent H parameter model. Equivalent H parameter model. So that means since it is what is this one? Common collector H parameter model. So common collector parameter kabatti H parameter equivalent of that one we supposed to draw. Is it okay? So that means we have to identify what is the input current, output current, input voltage, output voltage. What is the input current, Ray? IB is the input current because this will gives you HR into V2. Yes or no? IB, and what is the current which is flowing inside, which is nothing but I suffix E, the current which is flowing through the IC. So what is the input voltage, Ray? Can you tell me? What is the input voltage here? Can I say VBE? Sorry,
Yes, sir.
Sorry, I should say VBC. Is it okay? VBC. Is it okay? VBC. Input voltage. And can you say output voltage? So what is the output voltage for this?
VEC.
Very good. VEC. VEC is the output voltage. Now we have identified. Now replace the transistor with its equivalent H parameter model. So that means this is nothing but a RS. This is a VS. Okay. Now we are having a R1 in parallel to R2. That R1 in parallel to R2, what do you say? Can you say something about that? Can I represent as a RB?
RI.
No, it is R suffix B. R suffix B. Is it okay? Now, observe here. So this is the base terminal. Let this is the base terminal. Let me change the color to identify that we are drawing a H parameter equivalent model. So this is nothing but now. Earlier it was HIE. Now what should I say this about this one? HI?
HIC.
Very good. HIC we supposed to say because the configuration we have changed. So therefore HIC we have to write. So therefore I can write here which is nothing but a HIC. So what is the current which is flowing into the base? Can I say that same IB? Yes, of course. And we are also having a HR. Can I write HRB or HRE here? Which one I have to write? Earlier it is HRE.
HRB.
No.
HRC, sir.
Yeah, HRC it should be. Why so? Because since we are using a common collector configuration, so we supposed to write HRC into. So what is V2? Actually, it is nothing but HRE into VCE. Am I correct? For a CE configuration. So let me write once again. So I'm always comparing with CE. Here, what is the component that we are writing? HRE into VCE. What is this VCE, Ray? Can I say output current? Yes or no? Sorry, output voltage?
Yes, sir.
What is the output voltage as far as this is considered?
VCE.
VEC we have to write, not VCE, VEC. Because at emitter tarvata collector దగ్గర నుంచి తీసుకున్నాం. Collector is grounded here. So this is plus and minus. Similarly, what you can say, here we are having a current source, and this current source is nothing but HF. Earlier it was HFE. What do you say about it?
HFC.
Very good. HFC. HFC into IB is there. That means that IB is nothing but input current. So here also input current is same. Are you with me, sir? Are you following? So here if you observe this input current IB, what I am highlighting is same. Yes or no? So therefore you can say that this one is also h of c into ib. So actually, strictly speaking, this hr into v2, when you are drawing a h parameter equivalent model, okay, and this one should be hf into i1. So v2 is nothing but output voltage here, and i1 is nothing but an input current. So output voltage is nothing but VEC and input current is IB. So accordingly we are replacing. Sir, everybody is following?
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Yeah. So now you just draw like this, and this is the across this we have to highlight, this is the base terminal. That means we are talking about this one. Let me highlight here. So that means we are talking across here. So across base till this we the entire thing is common. Now what is the other one? 1 by which one? I have to write 1 by, earlier it was HOE. What should I write
HOC,
here?
sir.
Very good, HOC. Till this are H parameter model. This is what whatever I have highlighted with a blue color, this one is nothing but your H parameter model. So anyways, this is the base. Let me write here, this is the collector, at this is the collector, and of course the emitter is grounded. So therefore I can say that emitter is grounded. So therefore okay, 1 minute. చెప్పండి పర్లేదు 12 to 1. Okay. So this one is nothing but a, what do you say, this one is nothing but a H parameter equivalent model. Here emitter is what do you say, emitter is grounded. So this way you can draw the replace the H parameter equivalent model. Now we are also having a only transistor is replaced so far. Other parameters are also there, no? So where is that? This one is nothing but your emitter. I'm sorry, I have wrongly indicated here. So this one is emitter, sir. Am I correct? This one is emitter, and of course I'm sorry, and this one collector is grounded. Are you people with me, sir? I'm sorry, wrongly I have designated here. So let me erase here. So this one is nothing but a emitter, and this one you can say this one as a collector. Sir, are you with me? Everyone is following?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, good. Now this is the I'm sorry, this is the collector terminal. Now draw the remaining part of the circuit. So if I draw the remaining part of the circuit, and this one is a emitter here, to the emitter we are having a RE. So that means we have to draw RE here, and which is grounded here, RE. And what is the other one? Other one is we are having a RL across emitter. We are also having a RL. What is the current which is flowing through this one? Is nothing but IL. So what is the voltage across this? Is nothing but a VEC. Now tell me which one is a RI, RI dash, R0, R0 dash. So where is RI or RI? RI is nothing but
R1
here.
parallel to
This is
that
RI.
RB plate.
This is RI dash. Please mention here. And this is R0. And this is R0 dash. Okay. What is the current which is flowing through this? So the current which is flowing through this is nothing but IA. Okay. At this junction, it is dividing as this current as well as some I and a current. Is it okay, sir? Everybody understood how to draw this? I mean, whatever I have drawn, this part, I'm highlighting this part. So whatever I am highlighting this part is nothing but a remaining part of the circuit. So whatever I have drawn with a what you call dotted lines, this is nothing but a H parameter model, H parameter equivalent model of the circuit. H parameter equivalent model of the circuit. Is it okay? Everybody understood?
Yes, sir.
Yes, sir.
Now tell me, what is VEC? What is VEC, right? VEC is equals to, can I say IL into RL? How the direction of IL? Can I say that minus IE? Same steps. Earlier it was IC. Now it is IE. Are you people able to follow?
Yes, sir.
Now third step. Is it third step or fourth step? Step
Fourth
4.
step, sir.
Yeah, fourth step. First parameter I am going to calculate as a AI. What is the definition for AI? Output current by input current. Which one is output current? IL by, what is the input current? Input current is nothing but a IB. IL by IB. But what do you know IL? Minus IE by IB. Is it okay? IE by IB. So calculate the ratio of minus IE by IB. To calculate the ratio of IE by IB, apply the KCL at emitter terminal. Apply the KCL at emitter terminal. So if you apply the KCL at the emitter terminal, so what is that we are going to get? IE is equals to what? IE equal to HFC into IB plus what do you say? Same steps what we did for last class. So what is that? If you want to know the voltage across, current across this, total voltage divided by this resistance. What is the voltage across this? That is nothing but VEC divided by 1 by HOE. Sorry, it should be HOC. Are you following? Yes or no?
Yes, sir.
Okay. So now IE is equals to HFC into IB plus HOC into VEC. But what is this VEC? Is nothing but minus IE into RL. Is it okay? IE is equals to, what do you say? HFC IB plus HOC into VEC I am replacing as a minus IE into RL. Now take IE common in this. If you take IE common in this, 1 plus HOC into RL, and this RL, I just wanted to make it as a RL dash. What is this RL dash? Can you say something about this one? What is I just wanted to make this one as a RL dash. What is this RL dash? RE in parallel to,
RE parallel to RL.
very good, RE in parallel to RL. So therefore, so what do you say? HOE into, strictly speaking, I am making this one as a RL dash. You know what is RL dash, and this one you can take it as a RL dash. HOC into RL dash, which is equals to HFC into IB. So what is the ratio that we require? Can I say that IE by IB? Yeah, IE by IB is equals to HFC by 1 plus HOC into RL dash. But from this, what is required actually? Current gain AI. What is the definition of current gain AI? Minus IE by IB. So IE by IB ratio we know. Minus IE by IB means minus HFC by 1 plus HOC into RL dash. Now tell me, what is the observation that you made from this? And I'm comparing this expression with the CE. So what is the CE expression, right? Minus HFE by 1 plus HOE into RL dash. Am I correct? But this RL dash in case of CE is nothing but RL dash is equals to RC in parallel to RL. But in this case, what is this RL dash?
RE parallel to RL.
Very good. So that means according to your what do you call this one, it will vary. RE in parallel to RL will be your RL dash. Can you complete rest of the parameters? Yes or no? Like this, can you complete the rest of the parameters? Yeah, however, we have derived same thing that we supposed to derive. Okay, so when you are substituting, no, you can take directly. When problem is given, you can write this expression directly. But when the people ask you to derive this expression, you have to follow this procedure. Is it okay? బాబు అర్థమైందా? ప్రాబ్లమ్ సీసీ మీద అడిగాడు అనుకో, డైరెక్ట్ గా మనం ఏవైతే ఫార్ములాలో యూస్ చేసామో సిఈకి సేమ్ ఆ సఫిక్స్ సెకండ్ సఫిక్స్ ని చేంజ్ చేయాలి. హెచ్ఎఫ్ఈ ఉందనుకో హెచ్ఎఫ్సి పెట్టుకోవాలి. అన్ని ఫార్ములా సిమిలర్ గా ఉంటాయి. బట్ ఆర్ఎల్ డాష్ దగ్గర ఆర్ఎస్ దగ్గర వేరీ ఉంటుంది. దట్ వీ నీడ్ టు టేక్ కేర్. But whenever parameters asked to derive, you supposed to do, you supposed to follow the procedure and we supposed to derive the expressions. Is it okay? So likewise, we supposed to derive the expressions, and please follow the procedure to do it. Let me complete today's session. Okay, so this is what we supposed to please complete the rest of the parameters. Okay, let us I'm stopping the class, today's class till here. Please complete the rest of the parameters to calculate. Can you do it, sir? Yes or no?
Yes, sir.
Yeah, please complete this. Let me take the attendance. Don't leave, sir. Let me take the attendance. Okay, thank you all. Thank you for joining. You can leave the meeting, but make sure that you have to calculate